Welcome to Foundational Patterns. In the previous lesson, we were discussing identification of two-dimensional shapes. In this case, we are discussing three-dimensional objects, or sometimes what they are called solid or solid figures. We will also refer to them as polyhedrons. So the word poly simply means many, and hedron means faces. So polyhedron means a shape or an object with many faces. So these are the three-dimensional shapes. So we're going to look into this one here, which is a more common one, which is a rectangular prism. With a rectangular prism, we will note that this part here, which looks like a rectangle or a square, is a face, and this one here is also a face, and we have another face. So basically it will have 6 faces because opposite each face that we have identified there is another face there. So then we are seeing 3 and there's another 3 at the back. And where two faces meet, like for instance here, this point here, we call it an edge. Where two faces meet, so this point here as well is an edge, and so on. Now where two or more edges meet, there's a corner there and a corner here, so these one we call them a vertex, and if there are many, they are called vertices. Okay, so this one here, it's a vertex. Another one here is a vertex. I think you get a point of what a face is, what is an edge, and what is a vertex. Here are some examples of what two-dimensional objects may look like. So we have here a rectangular prism. Alright, some few examples of a rectangular prism. We have here what we call an eraser. Some of you will call it a rubber. And then we have a book. A book has a shape of a rectangle, but because it has some pages, then it will have some width, and with that it becomes a rectangular prism as well. A box for presents is also a rectangular prism. And then we have what we call a cube. A cube, some few examples of a cube will be a die, alright, and another one will be a Rubik's cube, so that's why it's a cube. And the most common one is an ice cube when you want something to be cold. And next we have what we call a cylinder, alright. So this is a cylinder. A cylinder basically it's something like a pipe. So here we have a water bottle, alright, which is in a form of a cylinder. We have a common one which is a gas cylinder that is very reliable during load shedding. And then a cup as well is in a form of a cylinder, because then it will have a round section and a curved section going down there. All right, so these are few examples of three-dimensional objects. Let's get some few more. And then we have what we call a cone. All right, some few examples of a cone. An ice cream cone, so this is what we know. All right, and we also see that Christmas hat is also in a shape of a cone, and this is a party hat, which is also a cone as well. And then next we have what we call a sphere. So with a sphere, examples of a sphere is a soccer ball, okay, and another one is a melon, watermelon, all right, my favorite, and a marble, or what we call the alley. All right, so those are few examples of a sphere. Now these three-dimensional objects or three-dimensional solids can be divided into two. So we have what we call pyramids, and we can also have prisms. So a pyramid is basically it will have a base. It can either be a square, a rectangle, a triangle, a pentagon. It doesn't matter. So we'll have a square, a base here, and then on the sides it will have triangles on the sides that go up and meet here at the top, and this is called an apex. So the vertex here where they all meet is called an apex. So that's what this one here is called, a rectangular based pyramid. Whilst another one we can have a triangle based pyramid where we have the base being a triangle, and then you see it has faces on the sides that are triangle as well, and we are meeting here at the apex. So this is a special vertex which is called an apex. So a pyramid will have only one base, and then it will have an apex. On the other hand, a prism will have two bases that are identical. Congruent means that they are identical. All right, so these are identical bases on both ends, and the sides of the faces on the sides of the prism will be a rectangle. As you can see here, this will have a rectangle. So this one here has rectangles as the bases, but then this one has triangles as the bases, but then the sides will be rectangles. Okay, I hope it makes sense. So the pyramid, it has one base and an apex, whilst the prism has two bases that are identical. With a pyramid, the sides are triangular faces. With a prism, the sides are rectangular faces. I hope you understand the difference between the pyramid and the prism. Now, some few examples of what a pyramid looks like. If you look at this one here, this one will have a base which is a triangle, and then on the sides it will have triangles as well. So this one with a triangular base is called a tetrahedron. So the word tetra means four. So it is a tetrahedron, right? Another one is when we have a rectangle based pyramid. All right, so there's a rectangle at the bottom, and then it also has an apex there. Then we have a square-based pyramid. All right, and then we have an octagonal-based pyramid, meaning the base has 8 corners there. And then we have a hexagonal-based pyramid. So the base is a hexagon, as you can see. And then we have a pentagonal-based pyramid. So this one has 5 sides on the base. So these are the types of pyramids. Now let's look at the types of prisms. Here we have a square-based. This is a square-based prism. All right, even though the sides are rectangle, but this side here is a square. And then we have a triangular-based prism, because this base here is identical to the other base on the other side. All right, and therefore we also have a rectangular based prism. All right, and a octagonal prism, a hexagonal prism, which means the base is a hexagon and it has 2 hexagons at the top and at the bottom. Pentagonal based prism, okay, or just simply a pentagonal prism. All right, next we want to look at those that are not prisms. All right, so these ones here, this is a triangle based prism or triangular prism. This one here, it has 1, 2, 3, 4, 5, 6, 7. So which means this one is a heptagonal prism. Alright, this one here is a triangular prism. This one is a pentagonal prism. And basically this one is going to be a hexagonal prism. Alright, then there are others that are not prisms. For instance, this one here is a rectangular based pyramid, so it's not a prism. This one here is neither a prism or a pyramid. This one also is not a prism and it's not a pyramid. This one here is a cylinder. All right, so we are sometimes tempted to say that a cylinder is a prism because the base on both ends are identical. All right, but with the definition of what a prism is that the prism must have both ends of the both bases on both ends being identical. That's number one. But number two, the sides of the faces must be rectangles, but then this one has a curved surface, so it is not necessarily a rectangle because it has a curved surface. All right, another one that fails to become a prism or a pyramid will be a cone that looks like this. So this is a cone. It will not be a pyramid, and therefore it also fails to become a prism. All right, so let's compare now. We have a triangular prism which partners well with a triangular pyramid. Okay, and then we have a square prism with a square pyramid. All right, and then we have a rectangular prism and a rectangular pyramid, as you can see there. All right, And then we have a pentagonal prism. As you can see, we have 1, 2, 3, 4, 5 sides on the base. All right, so this then becomes a pentagonal prism. All right, and as you can see here, we'll have the same. It has 5 sides on the base, so this is also a pentagonal prism. I mean a pyramid. Yeah, the prism and the pyramid can be confusing sometimes, but just follow on. Right, next we have a hexagonal prism, and we have the hexagonal pyramid, and then we'll also have an octagonal prism and an octagonal pyramid, and this can continue forever as long as you are able to draw the different types of these 3D shapes. Okay, so next we want to discuss the nets of the solids. All right, so look into this one here. This is a box. Okay, a box. It might be a box for presents, box for chocolates, box for shoes. Doesn't matter really what it might be. But then here, this is the lid of the box, or we can say this is the top of the box. All right, and then this one here will be the bottom of the box. So this one here is the front, and this one will be the right hand side of the box, and obviously this one will be the left. Okay, and the one that we don't see here is the back. All right, so basically that's what you might have. Now if you open this box and flatten it, you will notice that you will have, this is the top side of the box, and this is the back. All right, and this is the right hand side, while this one becomes the left, and you'll have the bottom. I hope you can see, and you have the front. So that's the net. Is basically when you have taken this box, you open it, and you then flatten it into a 2-dimension. So you're taking a 3-dimensional object and then you make it a 2-dimensional shape like that. And so you dismantle it into its pieces that makes it. So because you can see it has two, the front and the back are of the same size. So it will have two sides that are of the same size, two sides that are of the same side here, and then this one here, it will have two sides that are of the same side. So these are the rectangles that we have dismantled these 3-dimensional shapes to become. All right, so that's basically what the net is. So the net is when you break down a 3-dimensional shape and make it to become a 2-dimensional shape. So you basically open and flatten the faces of a 3-dimensional shape to become 2-dimensional shape. All right, so let's look at some of the nets. We will not look at all of them, but the few that we will look at will suffice to actually build a picture in your mind. The first one here is when we look at a rectangular prism. So this rectangular prism here, when we dismantle it and flatten it, you'll notice that this one becomes this side here. All right, and then the top and the bottom are the same, so it will be this one, and it will also be this one there. Okay, so that's what it will become. And now the front and the back are the same, so we'll get this one to be the front and the back will come there. So now we have covered all 6 sides of the rectangular prism to become its net. Now if we take this square based pyramid, you will notice that once you open it, so we'll have the square as the base, and then the faces of this pyramid are triangles. I hope you can see that the faces are triangles. All right, then we have the cylinder. This shape here is the cylinder, so when we open it and flatten it, it becomes a net with a rectangle there and 2 circles that are closing the top and the bottom. So that's what makes the cylinder of the three-dimensional object, which is called the cylinder. And then the cone has a circle and a curved part here, so when we open it, so we'll get a circle and this shape here, which is part of a circle. All right, so that's basically what, when we break down the three-dimensional solids to become the two-dimensional nets of the shape. That's how it becomes. Now next we want to look into how then do we build up the three-dimensional shapes from the net. So if you look at this one here, we have a net of a rectangular prism. So a rectangular prism sometimes is called a cuboid. So you will notice that we have 1, 2, 3, 4, 5, 6. So this rectangular prism is basically a square based rectangular prism, because you will notice that it has a square here and a square here. Alright, so when we close it up, then it becomes this square based prism. Alright, this one here, it's a net of a triangular prism. So when we close it, we get a three-dimensional object, which is called a triangular prism. As well as when we look at this one here, we have a square in the middle and we have triangles, 4 triangles to be precise. So when we close it up, we have a square based pyramid, all right, with an apex at the top there. All right, and then this one here, we have a rectangle and it has a circle at the top and a circle at the bottom. When we fold this rectangular section, then we will end up with a pipe looking like a shape, which is called the cylinder. All right, so that's basically what we talk about when we talk about the nets, and this basically concludes our discussion on the 3D objects. And let us know if you have any other thing that you want us to discuss, any other topic that you want us to discuss. You can write your comments in the comment section, or on the other hand, you can send us an email on mlms4@foundationalpatterns.org.za. All right, so in our next lesson, we'll be looking into calculating space in two-dimensional shapes. So when we talk about space, we'll be talking about perimeter as well as area of the two-dimensional shapes. So thank you for tuning in. See you next time.